We are about to start, and it's my pleasure to introduce GT with the state of the metric start SDK in 2024. Stage is yours.
Thank you. I hope everyone's comfy. We are going to talk about the state of the Matrix Start SDK. I added the year because I thought I could do this like incrementally every year, but that might not be that interesting. So like every 2 years or 4 years, you should see this talk pop up again. Short intro, I'm TD, that's my matrix and my email. I do matrix and WebRTC stuff at Famedly, which maybe you know, maybe you don't, but well, that's good enough. So what is the Matrix Dart SDK? It's a Matrix SDK written in Dart, and while I was talking to someone over here, they said that Dart is a very esoteric language, but come on, it's by Google. Has Google ever done anything esoteric? But so it's a type-safe language and it has some pretty cool features. But the main advantage for Dart, I would say, is it's a very easy to pick language against, like, say, for example, Rust or something. So if you do JavaScript or something like that, I would assume that you are writing efficient code with Dart in like a couple of days or a week at max. But apart from just the Dart part, Google also gives the Flutter SDK, which then compiles, cross-compiles to multiple platforms natively, so Android, iOS, web, and all of the desktop platforms. Back to the Matrix Start SDK, we just released version 0.33.0, which was a breaking change, but well, it basically added some new endpoints and stuff, and it's Semver, but Dart follows like zero Semver or something before version 1, in which basically your Semver guidelines are moved one column to the right. But yeah, who's it made by? It's made by the team at Famedly, and it also has external contributors because it's like open source and under the AGPL license. But like the main point why I mentioned this is it actually has a bunch of people behind it. It's not a solo project, and it's already been fairly well used out in Germany, which we'll see after this slide. Apart from that, it's fairly well tested. 60% is not a really huge number, but hopefully that increases in the next iteration of this talk. So who's it used by? It's used by Gematik as their reference SDK. Gematik, if you have already been to their talks, is the TI messenger. Well, Gematik technically does a lot of things, but what we are interested in is the TI messenger part. So it's a reference SDK for the TI messenger. It's also used by all of the pharmacies in Germany via Gedisa and like the ambulatory care services. So it's a major part of the healthcare system in Germany. If it's of course used by FluffyChat. If you're a Matrix enthusiast, you probably know FluffyChat. At some point, it probably maybe will be used by insurance providers and like insurance consumers. That's a maybe because there's still like tenders and stuff going on. But yeah, Famedly will figure that out. And of course, it's used by Famedly, which is an approved TI messenger, and I believe it's the only one yet. There could be others, of course. But yeah, as you can see, it's already widely used in the healthcare ecosystem all across Germany. So a quick rundown of the structure. I was going to add legends over here for the colors, but well, I'll just wing it. The red part you see over here, you're never going to have to touch that, but I just wanted to give an overview how the Matrix Dart SDK is built. At the bottom, you have the Dart Open API code gen. For those of you who don't know, the Matrix spec also gives you the Open API spec or the Swagger spec, whatever you call it these days, and we generate the low-level request endpoints directly from this Open API spec. And this has like a very minor but neat feature, in my opinion, is that it also copies the Matrix spec doc strings directly into your code. So if you have like a fancy linter or something, you could just hover on your functions and then you have the Matrix spec right there. Or for example, if you go in the Matrix spec Matrix Dart package documentation, you basically have the Matrix spec for the login method right below the login call. And I think this saves a lot of time because I'm pretty sure at least a matrix developer opens spec.matrix.org at least once every day. Apart from that, you have, Olm, libOlm. We'll talk about cryptography after this, but we have libOlm, which does the cryptography stuff, and on top of that, we provide a Flutter package, which is FlutterOlm. It's technically a Dart package, but apparently it's called FlutterOlm now. Which is basically Dart bindings for libOlm, and then you can just import it in your Android or iOS project in your pubspec.yaml, which is the equivalent of package.json or requirements.txt. And yeah, so you only need to import this one package, and all of the cryptography stuff is automatically enabled for you. You don't have to do anything else. For web, we also provide a WASM bundle. And I believe for Windows, there's a 32-bit or 64-bit DLL. And for Linux and macOS, I think you just need to ship libOlm. But that's the red part. That part you're never going to have to touch. But then we come to the Matrix Dart SDK, which is basically an extension, which basically extends the Matrix API auto-generated by the OpenAPI CodeGen. And this stores all of the logic, the state, the database stuff, and the features we use, and the features inside. On top of that, you could, for example, extend it. We do this at Famedly for like TI Messenger specific stuff, but you don't really have to do this. We, of course, we have tried to make the Matrix Dart SDK as more modular as possible. We'll see these modular features in the next slide. But apart from that, if you want to like create a completely new client, like the TI Messenger stuff has some strict guidelines, so we needed to extend the whole SDK. But that's really easy. We have already done that. And then the clients like Fluffy Chat and Famedly can just directly consume the Matrix Dart SDK or the TI Messenger client SDK. So features. While I go through this list, it's not an exhaustive list. These features are basically what I think are really cool and maybe unique to the Dart SDK. But yeah, I think we should go over these, and hopefully when other SDK developers or client developers watch this, they can implement these features. We'll quickly get over the boring stuff because every SDK or client needs to have a database. By default, we provide a SQLite backend or IndexedDB on web. But if you don't want to use this, there's of course a thin database API which you can implement. And when I mean implementing an API, you basically need to tell us what needs to happen when you do like a read or a write, and then the Matrix Dart SDK automatically starts using your database. We do this in Famedly, for example, and maybe it's also done in Fluffy Chat, where we want to encrypt the database for native platforms, but not on IndexedDB, but not the IndexedDB. So the native part implements the database API, which then does the encryption stuff on start and close. And then, of course, there's a really small caching layer, which is updated every read and every write. And this is what makes opening the Fluffy Chat room the second time quite faster. This is also kind of database focused, but I thought I would put this in a different slide because we do these tweaks to make sure the client feels as snappy as possible. So for example, we store the last event of a room separately because when you open an application, you want to see the room list as soon as possible. And then most probably you also want to see the preview message. This could be done in sliding sync, but that's still not a thing. And that won't work in offline mode. So this is kind of taking that part of sliding sync and implementing it on the client side. So we store the last event of the room separately, and then that makes the database queries faster because we don't have to get the whole timeline chunk. We just get this one message. It, of course, supports complete offline mode, so you could open it when the app is offline, and it should just work. The timeline also has some really cool helpers where you can, where you get the particular index for when a message is updated. So you could granularly update just that one UI part of your screen, for example, and then like you can do some rendering optimizations because we did run into some problems, and that's why this is there now. And we also have this concept of important state events. I think other SDKs might have this, but in this we basically don't load the state of the room at the start. We of course have some important state events by default, like the encryption status of a room, the name, the avatar, etc. But you can of course extend this list of important state events. For example, we do this in the family app, where the group calls are under a com.family.call.member state key. So we just add this state key as an important state event, and whenever the app loads, it gets these events and not the rest of the events, and then you can have this nice little indicator that there's an active call in a room. The crypto, this will also be fairly quick. Currently, we use Olm. The minimum version we need is version 3.2.7 because it has some fallback key functions. And yes, I know everyone wants to ask if there's going to be a move to Vodosemac. Yes, it is planned, but apparently it does not have some features like the key backup function is not in Vodosemac, but in the Matrix Rust crypto something thingy. And that's like one of the blockers right now. But we have a private experimental repository. So this is also on our to-do list, yes. Another nice little feature we have is the compute API. What this allows you to do is have right now the list of functions is very limited, but these functions can run in a separate thread or a web worker, for example. And we have tried to keep this list short because we don't want to access the database via multiple threads. So these are purely arithmetic functions, and these just return the result back to the main thread. And of course, if anything fails, it falls back to the main thread. Everything is reactive and observable, like every other SDK, but I really like how Dart handles reactive streams. So if you want to see if the login state has changed, you basically just do client.onLoginStateChange.stream.listen, and then you have it. These are a couple of other examples for key verification, participants change in a call. And all of these are typed events, but of course, if you don't find something which you like, you can just listen to the on-sync stream and then pass the data out manually. Native RTC is also one of the, I think it's a unique feature. Apart from the Matrix JS SDK, the Matrix Start SDK is the only other SDK which has pure RTC bits implemented. So if you want to do something related to RTC and not use Matrix JS SDK, you probably want to use the Dart SDK. And by that, I mean it has native peer-to-peer WebRTC support. But apart from that, it also allows you to plug in RTC backends, call backends, we call this, for group calls. By default, we support LiveKit and Mesh as a backend for a group call. But if you watch TWIMS, there was also a demo of Cloudflare as an SFU for Matrix RTC implemented using the Matrix Start SDK in the family app. So as you can see, it tries to make stuff really easy for you, and hopefully that makes sense. But that's a perfect segue to well, not that, but it actually makes stuff easier for you. The UI, so I tried to go into a couple of different SDKs and see how the other SDKs do this. This is not a diss on other SDKs. I just tried to see how some of the complicated bits of the Matrix spec are implemented in the other SDKs. So the user interactive authentication, for example, is something complicated in my opinion. And on the right, you see the Rust SDK, which is basically trying to do the register endpoint. The register endpoint is a UI endpoint, and if that fails, it checks if the error response is a UI error response, and then retries the endpoint with the authentication stuff. On the Dart side, you just need to wrap your endpoints in a UI request background callback, and then the auth stuff is automatically sent into it. And then you just need to, in somewhere in your app, listen to the UI request stream, which will basically, whenever endpoint needs UIA, an event is fired on that stream, and then you can show the user a pop-up which should ask for the credentials or something like that. The recovery key mechanism, I was going to try and put screenshots from the Rust SDK, but this process was super complicated and was not going to fit on a single slide. So, well, I tried to do my best. But that's not even how the Dart SDK does it. It's just snippets of the code. But I like what the Dart SDK does over here. It's basically just one function call, the client.encryption.bootstrap call, and every time the bootstrap state is updated, the onUpdate callback fires, and you just need to listen to this bootstrap state, and then it gives you like these flows where you want to either wipe this recovery key or use the existing recovery key, and you can then listen on the bootstrap state and handle the UI accordingly. Key verifications are very similar to that. As you can see, we have tried to keep the API similar to the bootstrap state. Here also you have an enumerated class which shows all of the possible states, and then you listen to the key verification state. And for example, if the current state of a request is ask accept, you probably show a UI over there, which is deny or verify, and then you accept verification, and then this automatically sends the ready event. One point I missed over here is that once you start doing the ask wipe recovery key thingy, the Dart SDK automatically handles the wiping the cross-signing stuff and then wiping the online backup stuff, creating a new online backup stuff. I believe in the Rust SDK in the Rust SDK, you need to like call these functions manually. So you need to have somewhat of an understanding of the recovery, the SSSS flow. But we have tried to make the Matrix Dart SDK a black box where you just use it and then forget about it. There's also easily pluggable call backends, as mentioned before. For example, here you have LiveKit backend and a mesh backend, and then it automatically fails over in a client. With this, you can just have a backend, and then you can use methods like enter or call backend or on participant changed and stuff. But then the low-level bits, like for example, LiveKit backend would require you to do encryption key stuff because SFU, S-frames, etc. But you don't have to deal with any of that. That's all handled in the LiveKit backend. You just need to use this top-level API. So next steps, the sliding sync support. Maybe if you saw Braid's talk yesterday, what she did was really cool. She basically, it's basically an implementation of the sliding sync proxy, but on the client side. So it was able to support both old home servers and new home servers. So that was really fancy. The migration to Odozimac is planned as stated before. There's also new authentication flow talks going around. So we probably will get to that at some point. We really need to work on better code gen because right now it's just a script we run. And recently it broke when we tried to update from version 1.6 to version 1.11 because the Matrix spec decided to update from OpenAPI version 2 to OpenAPI version 3. So we need to make that a bit more robust. Some database tweaks because we already know, like I know one bug, I found it yesterday, but we need to make the database, we could probably do the database stuff a bit better. And of course, if you were here in the talk before this, we are trying to, we might also try to look into the complement crypto stuff, which basically tests SDKs against each other for making sure the crypto stuff works and you don't get UTDs. But yeah, hopefully that goes on our to-do list at some point too. So thank you. Do you have any questions now?
Thank you very much. And yes, we have 10 minutes left, so we can throw a bunch of questions to DD.
It's not really a technical question, but is this SDK the basis for all of Fluffy's applications, or is this just for Fluffy Chat?
It is used in Fluffy Chat, but Family is a TI messenger, so it needs to do some TI messenger additions over this SDK, but this is the base, yes.
Okay.
Thanks. Any other question left? Everybody wants to have a coffee, I think. Okay. Yeah.
Yeah. Hey, thanks for the talk. In a previous talk, I think Timo or somebody else mentioned that sometimes SDKs behave a bit too much like black box, especially in terms of storing the four main keys. What do you think about that in regards to what you said, that the Dart SDK tries to like opaque it as much as possible?
Yes, I picked the black box term exactly from that talk. But you might need to sometimes look into the recovery thingy if you want to implement something fancy. But if you're just trying to get a client started in a week or so, I think this approach makes sense. But if you're trying to look into how to get into the internals, we have like super well documented code. If I like go over here, so for example, key verification. So for example, we have like really good docs. For example, this is just the QR key verification stuff and how I had to implement it. But so it is a black box, but then you can maybe hopefully easily dive into. And if that doesn't work out for you, there's of course Fluffy Chat, which is a public implementation. So you could just look into how Fluffy Chat does it and hopefully understand it that way.
Thanks a lot. And
well, not a question, but to add to that, in the Dart SDK, we have several layers. So we have the lowest layer with just the API calls. So you can always go to the lowest layer, call the API directly. Then on top of that, we have some foundational stuff to implement those backboxes that you can always dive down to that layer if you want to do some custom stuff. But at the very top, we have easy to use black boxes. When you just want to send an encrypted message into the room, it just deals with that for you. And you don't have to do like 10 different calls. You just say send encrypted message and it does it for you. But the other layers are still available. You just don't have to deal with them by default.
thank you very much. And now it's officially time for coffee for everyone. And we see each other probably again at 4 o'clock with Timo, Matrix RPC.
Thank you.